Hey everyone, Mike Mutzel here. I want to share some really great information with you. In the last 2 weeks, we've had a lot of great research articles dedicated to the intestinal microflora and the intestine itself. And I want to start out by just talking to you a little bit of background, as this was published yesterday, June 13th, an update with regards to the Human Microbiome Project. And if you're not familiar with this, I'd recommend checking out these two sites, the June edition of Nature and the Public Library of Science, known to be PLOS ONE. And if you're not familiar with this, just a quick appraisal: more than 80 research universities have come together via NIH funding, roughly $173 million, dedicated to really understanding the impact that the microflora inhabiting various tissues of our body impact health, and not just the intestinal or mucosal microflora, but the skin microflora, the nasal, urogenital, and so forth. So this is some really interesting research that's emerging. Multiple human healthy donors are contributing to this, and so forth. Along these lines, there's been a little bit of an update. As you know, the microflora inhabiting our body is 100 times more microbial cells than human cells. And while that information is not new, the number of species has been updated. Individuals prior to the Human Microbiome Project used to report in scientific journals that there was about 1,000 different species. I've seen that number reported up to as high as 35,000 species, but it turns out there's approximately 10,000 species, at least according to this new update in the Human Microbiome Project. And another update would be the quantity of genetic material. We used to think that the human microbiome contains roughly 100 times the amount of genetic material when compared to the human genome. However, we know this now to be wrong. It's roughly 360 times more genetic material found in the human microbiome. And Science Translational Medicine have just published a new, what they call, joint special edition. And this is an excellent edition. I'm going to show you a couple different studies from this particular edition that was published on June 8th. Some really great researchers, Patrice Canny, for example, Dr. Hooper, Dr. Jeffrey Gordon from Washington University, and so forth. This is actually an update. If you're not familiar with science, I'd recommend checking out their website. I think it's just science.com. They have a lot of great translational articles, and this one was particularly important. And for those of us that have children in particular, we know that early life events, whether it's birthing, a method, introduction to solid foods, antibiotic exposure to non-steroidal anti-inflammatories, proton pump inhibitors, and so forth, have a profound effect on the development of the early intestinal microflora, which then can impact later life physiology and predisposition to diseases related to metabolic disorders and immune disorders. And this was a really nice paper. Dr. Hooper talks about the inside-out control, and what she discusses is this sequestration and what she called compartmentalization of the intestinal microflora, and the two ways that the immune system really can help to protect itself, or the body at large can protect itself from the intestinal microflora, is by constantly sampling the antigens inside the gastrointestinal lymphoid tissue, as you can see down here, and then causing an increase in immunoglobulin production to neutralize those different antigens. And we used to think of this basically as just the barrier, just kind of like a more mechanical aspect in terms of protecting the penetration of these antigens. But we know it's an inside-out control, literally a two-phase process by which the intestinal immune system helps to really keep these guys at bay. And should they cross, in the case of intestinal permeability increases, well, we know that these guys hopefully are going to be limited to the lymphoid tissue known as the gastrointestinal lymphoid tissue, and antibodies will be made against them. So this was a really great article. And again, like I told you, there was 5 review series dedicated to the intestinal microflora. This was another one by the European Society of Clinical Microbiology and Infectious Disease. A lot of great research articles. This one in particular on human milk oligosaccharide consumption. This doctor from Stanford University talks about the 200 plus oligosaccharides, which we know, inulin and glucaride and fructooligosaccharides. All these prebiotic components really prime the anaerobic microflora, which, as you know, are Bifidobacterium, Clostridium, and Bacteroides in the infant intestine. And these anaerobic bacteria are increasing in the infant intestine right after birth. And these fructooligosaccharides and galacto-oligosaccharides and so forth from human breast milk really favors their development. This is a researcher that you really need to become familiar with, Patrice Canny out of Brussels, and he's highlighted a lot of great articles pertaining to metabolic endotoxemia, which, as you know, diet-induced obesity, which would be high-fat diets, cause a translocation of this gram-negative bacterial component called endotoxin, and this endotoxin is known to stimulate macrophage activation, leading to increased cytokine production, namely interleukin-6 and TNF-alpha. In so doing, creates increased adipogenesis, or the formation of fat cells. And there's a new mechanism, and Dr. Canny talks about this in this review series, where the intestinal-derived endotoxin actually triggers the activation of the intestinal cannabinoid system known as the endocannabinoid system. And this endocannabinoid system targets the fat tissue, causing increased adipogenesis. So it's really a twofold process by which diet-induced changes in the intestinal microflora, causing barrier defects, causing dysfunctional endocannabinoid system signaling, leads to increased adipogenesis and fat cell formation. As we know, fat cells tend to spill over inflammatory cytokines and adipokines such as leptin and adiponectin and so on, and this can lead to their detrimental systemic, inflammatory, and metabolically disruptive effects. So that's it for this week. You can check out my blog, MikeMutzel.com. I have a book coming out here at the end of June that should highlight some of this stuff in a lot more detail for you.